The third transformation that we're going to learn about is a rotation, or more commonly called a turn. And a rotation or turn of x degrees about a point R is called the center of rotation. Its transformation with these two properties. The image of R is going to be itself. So if you look at point R in the diagram, the image of R is R prime, and they are equivalent. For any other point V, if you look at point V in the diagram, then the length of segment RV prime is going to be equal to the length of segment RV. Notice the congruence markings on those segments. And the measure of angle VRV prime is going to be the measure X. That's the angle of rotation. The positive number of degrees a figure rotates is called the angle of rotation. And a rotation about a point is an isometry. If you remember the definition of isometry, it means that it preserves segment lengths and angle measures from the pre-image to the image. So before a figure is rotated and after a figure is rotated, they will be congruent. It's important to note that unless it tells you otherwise, all rotations are considered to be counterclockwise. So remember, counterclockwise is to the left. If you'll look at the ACT problem below, many rotations can be visualized simply by turning your paper. And that's an important thing to note, especially on tests like the ACT. So in this diagram, in this question, it says, which of the following are the coordinates of the image of D, so you're just looking at point D, under a 90-degree counterclockwise rotation about the origin. So if you would just take your paper and turn it a quarter turn to the left, that would be 90 degrees. Because the 90 degrees is a fourth of 360. 360 would be a complete turn. But we only want to go 90 degrees, so it's a fourth of a turn. So if you turn your paper sideways a quarter of a turn, then where does the point D, where is it going to lie? So if you turn it a quarter of a turn, point D is going to be D prime, if you want to call D prime, is going to be, it's going to go here, and it's going to be F, -5, -1. So that's the easy way to do some of those problems. If you would go back to the previous page in your notes, there's a rotation problem at the bottom of that page. It's problem 8, drawing a rotation image. So let's look at that first. It asks you to trace the figure and point P on patty paper or parchment paper. We can do that in class, but we can also do it here and talk through it as well. But to draw the image of the figure for the given rotation about point P. So point P is where we're going to rotate it about that point, and the given rotation is it wants to rotate 90 degrees. And it always means, if it doesn't state otherwise, it means counterclockwise. So that means that you're going to rotate it to the left. So if you do that, rotate it to the left, then I'm going to draw a dotted diagram that's going to be where that figure is going to, the image is going to be. So P is going to equal P prime, because we're rotating about point P. It stays the same. The K goes down to K prime here, and then the T comes over to T prime. So that's what that rotated image about point P is going to look like. So now take a look at problem 9. It's identifying a rotation image. It indicates that point N is the center of a regular hexagon named GEOM. What is the image of the given point or segment for the given rotation? Now, the fact that it is a regular hexagon tells us that all of the sides of the hexagon are equal, and all of the interior angles are also equal. So all of these sides are congruent, and all of those interior angles are congruent as well. That also tells us that each one of these interior angles, if we were to go all the way around, we would have 360 degrees total. So that means that each one of these sections is 60 degrees. Okay? So that will help us with this problem. The first question, A, says for a 60-degree rotation of X about N. So here is X, and we want a 60-degree rotation, so that's one section of the hexagon, about point N. So N is the center of rotation, and we're going to go counterclockwise 60 degrees. So where will point X lie after it's rotated 60 degrees counterclockwise? It will be at point A. Next question is, with 180-degree rotation of HE, here's HE, 180-degree rotation of HE about point N, where will that then lie? So we're going 180 degrees counterclockwise, which basically just flips it. So where is it going to lie? HE is then going to be where segment AG is now. In problem 10, it's having you find an angle of rotation. The question is, what is the measure in degrees of the angle of rotation about point O that maps in point N to point L? So you might be tempted to say, oh, you just have to turn it 90 degrees, and I would have N at L. But be careful, because all rotations have to go what direction? They have to go counterclockwise unless it states otherwise. So here we have right angles on each of those intersections. So we're going to go 90 degrees, and another 90 degrees before point N gets to point L. So the degree of rotation is going to be 270 degrees. The last problem is problem 11, and it's finding a composition of rotations. So you have a rotation followed by another rotation in this problem. So it says, what is the image of quadrilateral ABCD for a composition of two 90-degree rotations about point A. So if you look at point A is your center of rotation. And if you turn it a quarter of a turn counterclockwise, then you're going to have A and B. And then you're going to have C and D. And I should say that that would be A prime, B prime, C prime, and D prime with one rotation. Okay? With the second 90-degree turn, it's going to take A prime. A prime's going to stay the same. And we're going to call it A double prime with the second rotation. B will become B double prime. C prime becomes C double prime. And then D prime becomes D double prime. So the image in red, this last image, is the image of ABCD for a composition of two 90-degree rotations about point A.